Okay, so welcome back. Now, in this example, the setup is going to be that we have a rock and we're dropping the rock from an initial height of 100 feet. Okay? And I think, is that all they tell us? Yeah, and the position of the rock t seconds after it is dropped is given by the position function here on the board. S of t is equal to negative 16 t squared plus 100. So now, the first thing that they want us to do is they want us to find the amount of time that the rock is in the air before it hits the ground. Okay? So to find that time, we have to set this equal to 0 because we want to know when does the rock hit the ground, which means the position of the rock is 0 feet above the ground. Okay, so this is the units of position is feet, the units of time is in seconds. Okay, so now if I solve this, what do I get? I get negative 16 t squared equals negative 100. If I divide both sides by negative 16, I get t squared equals 100 over 16, which is the same as 25 over 4. And of course, if I take the square root of both sides, I get t is equal to the not the absolute value, the plus or minus the square root of 25 over 4. Now, in this case here, we're dealing with time, so context is important. Time is not negative, so we can drop the negative part. And so this is going to equal 5 halves. Okay? So the rock is in the air for 2.5 seconds. Okay? So that's the answer to the first thing. The second thing they want us to do is find the average velocity of the rock for when the rock is released and when it hits the ground. So again, average velocity is going to be a change in position over change in time. So since we know the initial height is 100 feet, and we know the final height is 0 feet, and we know that the time goes from 0 to 2.5. So it's going to be a change in the position over change in time. So it's going to be s of 2.5 minus s of 0 over 2.5 minus 0. Okay, or if you want to leave this is 5 halves over 5 halves, that's fine. And so what do we get? Well, we already know what s at 2.5 is. It's 100, right? Okay, so it's going to be 100 divided by 2.5. So, what does that tell you? That tells you that the average velocity is going to be what? 40 feet per second. Is that right? Let me just check. Yes, 40 feet per second. Okay, because if you just move this over here and you put a 0 there, 25 goes into 100 4 times, add a 0, 40. Okay, so 40 feet per second. All right, so now we've got the average velocity from the time that the rock is let go to the time that the rock hits the ground. Now, it says, find the time t guaranteed by the mean value theorem when the instantaneous velocity of the rock is equal to the average velocity. Well, this is where we're going to use the derivative of the position function to get velocity, right? Instantaneous velocity is given by s prime of t, which is equal to negative 32t. And we want to know when this is equal to 40 feet per second. Well, now all we're going to do we're going to divide both sides by negative 32. Oh, hold on a second. Hold on 1 second. Hold on. I knew that something was right. This is minus 100, so this should be negative 100, right? So this is 0, this is 100, so it should be negative. Okay, so this should be negative. And that should make sense, right? Because we're going down towards the Earth, so velocity is in the negative direction. Height is decreasing. Okay, so now that means this looks correct now because, hold on. Yeah, because time should be positive, right? And time was going to be negative. That's how I saw that there was a problem. Okay, so now, what do we get? We get t equals 40 over 32. Which is the same as 5/4. And so when the time is 5/4 seconds, or 1.25 seconds after the ball or the rock is dropped, that's when the instantaneous velocity of the rock is equal to 40 meters per second, or negative 40 meters per second. And that's it. Have a great day.